Another important feature about LCR circuit is that when we made this diagram, this one, that here we have ER, then voltage across capacitor, then voltage across inductor, and then this much part was EL minus EC, and we found the value of net voltage through which we figure out the value of impedance. This part, if you take in terms of resistance only, so you can make this diagram like this, a triangle, right, where this, if this is representing the resistance only and this is representing resistance of EL and EC, that means this will be XL minus XC, then this angle is phi, and consequently the resultant resistance is Z. So Z or Z, whatever. So this thing gives you two important facts. Number one, this is called impedance triangle, and from impedance triangle the first thing you can find out is the value of tan phi. What is tan phi? XL minus XC over R. This will give you the value of, when I wrote that current could be in some phase difference with the voltage, which can be figured out later. This is the point from where you can calculate the value of phi, what is the phase difference between current and voltage. Number two, you can find out the value of cos phi. What is cos phi? When we will do the average power, you will see that average power associated with LCR circuit contains this part which is called power factor. This is called power factor. So this power factor cos phi is basically, what is cos? Base upon hypotenuse, that means R over Z. So these are the two important points which are also associated with the LCR circuit.